A random variable is a variable whose value is a numerical outcome of a random phenomenon.
Let's explain discrete random variables. So we have Garfield's 13th book. We have a plushy eagle. We have a leather belt. And we have, lastly, a plastic trout. Okay, so we have 1/2 of a chance to get an animal and 1/2 of a chance to not get an animal. And the sum of the probabilities for each individual outcome is equal to 1. And we drew a plushy eagle toy.
An example of a discrete random variable would be a coin toss because there's a countable number of possible outcomes, heads or tails. Looky here. Heads. Action. Heads again. Tails. Tails. And congratulations, it's another head. The last example was a discrete random variable because we could say there is an equal probability of pass or fail. There's heads for pass, tails for fail. We'll say that for the purpose of the experiment. So we had about a 60% success rate, assuming that was a perfectly fair coin. This number line here is a good example of a continuous random variable because, for example, there are infinite decimals and mixed numbers on the number line. However, since it goes from -1 to 2, we can say that 50% of all the numbers are going to be between 0 and 1.
Okay, we have here a discrete random variable. This is because we have a certain number of events that we can count, and we can also count the probabilities that we have right here. For example, you have the numbers 2, 2, 1, 2, 0. So you're able, if you are to create a problem out of this, you can just say, I want to pick a number 2, and you're able to calculate the probability of picking that. That is discrete random variable. As for continuous random variable, you have an infinite amount of decimals that are right between 0 and 1, so you're not able to really count them.
Okay, now we're going to talk about the z-score using these tangerines. As you can see, I have 13 tangerines arranged in a normal curve with a mean of 5 and a standard deviation of 2. The z-score is a standardized value of normal distributions with the random variable x minus the mean divided by the standard deviation. So to calculate the z-score of that tangerine example, we take z equals x minus u mu over standard deviation. So we get x is 13, total number of tangerines, minus 5, the mean, over 2, which is the standard deviation, which comes out to 8 over 2, and we end up getting a z-score of 4.